Oh, the whispering again. Yeah. Last time we were looking at derivatives, second derivatives, turning points, minimum, maximum, concave, convex, tangents and normals. Okay. So now what we'll have a look at is something called the antiderivative. And so take something like x squared. What's the derivative of x squared? 2x. So what the antiderivative does, it goes backwards. So the antiderivative of 2x is x squared. However, there's a small problem. So if I have x squared plus 1, plus 1, what's the derivative of that? 2x. And you have no idea that you were supposed to have a plus 1 at the end because it's lost. You know, if I change this to plus 4, if you start here, you don't know where you must finish because you don't know if it's x squared plus 0, plus 1 or plus 2. This information is lost. So what we normally do is, we put in a c. So if you have 2x, the antiderivative is x squared plus some constant, which we just call c. We don't know what it is. So what symbol do we use when we mean antiderivative? Well, the way I write it is like this. So this symbol with the dx, that means what is here, find the antiderivative. And the answer is x squared plus c. You can always check that it's right because if I take the derivative here, what should I get? I should go and get 2x, which I do get. So antiderivative and derivative, they go together, of course. Antiderivative is just the reverse of the derivative. So with that in mind, let's make the formulas. There are literally backwards to the formulas you had last time. Can I go down? Yeah. So here is our function, and then here is the antiderivative. Let me just draw a table first. Now, by the way, this means antiderivative. Some people, quite common, they write it as a capital to show that it's antiderivative. I don't mind. It's not very common, but I mean, I've seen it a lot. So, you know, it's not unheard of. But I'll stick to this. Now, antiderivative is fine, but there is another word that means antiderivative, and maybe it's the word you learned in high school. Does anybody know another word for antiderivative? Integration. Yeah. So what's the verb? Integrate. And what else do we have? Oh yeah, so what is this called? The noun, I should say. So integrate is the verb, means anti-differentiate. What's the noun? Not quite. What is it? So, the verb is integrate. The noun is integral. Yeah. The noun is antiderivative, and the verb is anti-differentiate. Okay. You can watch the video again to hear those, okay? But I'll say them one more time, okay? So the nouns, no, we'll do the verbs, they're easier. The verbs, so there's antidifferentiate. So it's like last week, what was the verb? Differentiate. So the verb today is antidifferentiate. There is another word, the noun is integral, and the verb is integrate. I usually stick with derivative and antiderivative for now, okay? So I'm going to say derivative for last week and antiderivative this week. Well, for this class. Maybe I'll change it in the next class, okay? Right, so let's have a look at the rules. So when we have, well, let's start off with something maybe a little bit simpler. If you have just a constant, you need to think, what was the function whose derivative is a constant? Kx, yeah. So what's the derivative of kx? It's k, isn't it? So the antiderivative of k is kx. Now, a little bit more difficult. What about x power n? Some people maybe know this one.
N plus 1 over
Hmm?
N plus 1.
That's it. You increase the power by 1. Remember, last week you decreased the power by 1. And what did you do last week after you decreased the power by 1? You multiplied. You brought the power into the front. So this week it will be divide by. Oh, of course, all of these answers have a plus c at the end as well. Sin x is minus cos x. Cos x is sin x. Ekx, what do you think that might be? Ekx, and where do I put the k?
Upper.
Not upper. Down below. Divide by k. Whereas last week we brought the k down in front. Here, divide. Does anybody remember the derivative of tan x? No? Yeah, 1 over. Yeah, but as 1 over, so it was 1 over. Yeah, which is 1 over. Yeah, you're right, it's sec, which is 1 over. Oh no. Cos, yeah. So the derivative of tan x is 1 over cos squared x. Therefore, the antiderivative of 1 over cos squared x is tan x. What was the derivative of log x? It was 1 over x. Therefore, the antiderivative of 1 over x is log x. Oh, by the way, I should say here as well that n plus 1 should not equal 0. So n should not equal minus 1. Don't divide by 0. Okay, let me see. We got sine, cos.
How about log x?
Semester 2. Yeah. It's more difficult than you might think because it's just log x, but it's actually a bit difficult. Okay, and then this one here, 1 over ax plus b, its antiderivative is 1 over a log ax plus b plus the c. Kx sine cos e. I think I got them all. Not to worry too much, because in the exam you get the formula book for these. But I think this one is not in the formula book. Instead, they just write it like this. Antiderivative of EX is, EX is EX plus C. So I don't think this one is in the book, and I don't think this one is in the book. However, this one you should figure out from last week. It's just opposite. So you might just want to make a note of this one. I don't think it's in the formula book. I have to check. Yeah? So let's do some examples of these rules. Can I go down? Yeah. Oh, and I'll give you some little hints as well, actually, that you might find helpful. So if you have something in here, like a constant multiplied by a function, dx. So for example, if you had something like 2 multiplied by sine x, it's fine to take the 2 outside. So it's equal to 2 antiderivative sine x. So you can take constants out. So the way I really like you to think about it like this, that this with something inside of it is a bit like you had some kind of brackets and something inside of it that you can pull out, you can factor out constants. So it might make your life a little easier if you can pull some constants out. Because this here you don't know, but this here you do know. It's in the formula book. So think of this as like a bracket. This is the start, and then this here is the end, and this is what is the question. And also what's very important is the x. If there's an x here, it means that inside the variable is x. So you could have something like this, t or 2t dt. That would just be t squared plus c. So they must match. If there's a t here, it's because there's a t on the inside. Yeah, will we have a look at some examples? Okay. So our first example to get us started. Antidifferentiate 14x plus 1 dx. Well, here it's like power 1. So this would be 14x, increase the power by 1 and divide by the new power. This one here becomes 1x plus c. So the answer is 7x squared plus x plus c. And this is from using, I used this one, the first and the second. Okay, let's try something a little more difficult. Let's try something like square root x dx. Get off the phone. There's no reason you should be looking down at your lap during class. Just up on the board. Okay, next one. So what should I do first? Yep, say again. 1 over 2 is the power. So I should first change this to power a half. And the rule is, I increase the power by 1, and I divide by the new power. So this would be 2 over 3 x 3 over 2 plus c. Or if you want, that's 2 over 3 square root x cubed plus c. Although for the exam you don't usually have to do this. this is fine. Yep. Okay. Try this one. Can I go down? Yeah. Try this one for me. 2 over E4x. Okay, try that. Yeah, finished? Or not? Got it? I think so? Yeah, it's easy. Got an answer? No.
Minus half.
Yes.
Or
Yes, should be minus a half in it, yeah.
in the bottom, like E4, 4x.
Yeah. So let's have a look here. What you should do first is take the 2 out. And then what you should do second is change it into this. E power minus 4x dx. And now it matches one of my rules I have. This is equal to 2e minus 4x over minus 4 plus c. So this is equal to minus a half e minus 4x plus c, or if you prefer, minus 1 over 2 e 4x plus c. Yep. It's okay? Alright. One more example. A little different this time. So do you think it's possible to find the c?
Yes.
Yeah, but what might you need or do to find the c?
A point.
That's it, very good. You can find the c if you have a point on the curve. So let's have a look at an example like that. Can I go down? Yeah, oh sorry, yep.
Or have degree. Not degree.
What no, not the gradients, no. It would need to be a point. Yeah. Continue? Yep. So, for example, I tell you f derivative of x is equal to 4x plus 3. So, what would f of x equal? Well, if the derivative was 4x plus 3, then you would need to calculate the antiderivative to go backwards. I also tell you that f of 3 equals 29. But that's for later. Okay, let's go back here. So this would equal 4x squared over 2 plus 3x plus c. So f of x, or the y if you want, is equal to 2x squared plus 3x plus c. But we don't know the c. But Yes, I told you at the start that f of 3 should be 29. In other words, 329 is a point on the curve. So, if I put that in, I get 29 equals 2 times 3 squared plus 3 times 3 plus c. So, 29 is 18 plus 9 plus c. So, c is 2. So, there we go. I now have my c is 2. Actually, I'll put it in here. C is 2. This is the answer. Is the derivative 4x plus 3? It is. And if x is 3, do I get 29? I do. So this is the answer. Yeah. They don't usually put this type of question in the exam, but I think they could, because everybody knows how to find the c. That's what we did in the first week. We use a point to find the c. So I could easily imagine an exam question like this, but they don't ask them like this. Okay. So what I'm going to do, like I said, I'll try and do the 3 lessons. So I want you to practice some of these for a few minutes. I don't think they're too bad. In number 1, JKL. N. JKLN. Yeah? All of number 2. Yeah. We're serious business now. Look how small. I mean, that's a big one. Like I think it'll take about 10 seconds a question. Well, maybe if you weren't distracted by your phone, it could take you 10 seconds a question. Just saying. You know? And then number 3, B. Okay, so you can try these for, let's see, what we say. Oh, 5 minutes is plenty of time. And then after 5 minutes, we'll have a look at the next lesson, which is very similar to this lesson. Yeah.
I lost my ticket.
How did that happen? Let me see. Left it on the bus. Left it in the library.
Might be in the class or I might have.
Left it in the class. Okay, that will do too. If you see me in the office, I'll print you another one. Yeah. Wednesday, do you have a break at 2 o'clock on Wednesday? Do you know your timetable?
Yes, 2 o'clock.
You're free at 2 o'clock on Wednesday? If you're free at 2 o'clock on Wednesday, if you come to the office, I'll print you another one then. Yeah? Okay. Alright, try these for 5 minutes then. I'll put the light back on.